So today we are going to finish up Chapter 5, Section 2. The homework tonight is 5-2C. When you're doing the homework tonight, you are going to need to show me the function table that you're creating, and then you're going to graph it by hand in Notability. I know WebAssign is just multiple choice where you just select the graph, but I want to see you graph it by hand in Notability because that's what you're going to have to do on the quiz. Now, the first example I do, I'm actually going to plug in a bunch of points to show you how your graph is going to approach the asymptote. When you go to do the homework, you only need to plug in 3 points. Give me a negative value, a positive, and a 0, and plug that in. And potentially also find the x-intercept if that'll help you identify the graph. So what you're going to need to do is you're going to need to be able to convert it from log form to exponential. Once we convert it to exponential, instead of plugging in values for x, we're going to plug in values for y. So we already saw the practice of converting from one form to the other. Then we saw the properties. We did a whole bunch of examples applying those properties and finding the value of x. Then we saw the natural log properties. And then we did examples yesterday, which brings us to the point of graphing. So again, you are going to convert from log form to exponential, and then you're going to make your little function table. You're going to plug in values for y, and then the answer you get is your x. You'll turn them into order pairs, and you're going to graph them. If you recall back when we graphed the exponential graphs, the exponential functions had a horizontal asymptote, which was the x-axis. The log graphs have a vertical asymptote, and that's going to be the y-axis. In the picture here, the blue graph is an exponential graph. The reddish purple color is a log graph. And as you can see, they're inverses. It's like a reflection. So let's go ahead and take a look at our first example. And we're going to graph this. We're also going to find the domain and the range. So the first thing we need to do is turn this into exponential form. So if it's better for you to rearrange it and put the y equals at the back, we have log base 2 of x equals y. What we're going to do is we're going to do a table. We'll have our order pair, which will be our final answer, our x column, and then I'm going to turn this exponential. So what I'm going to do here in the middle, this is b, a, e. So the exponential form of this is 2 to the y power equals x. So that's what I'll put here. And then you're plugging in y values, not x values. So I'm going to plug in a bunch for this very first example. However, moving forward, I'm only going to plug in maybe 3 or 4 at most. So I'm going to plug in first -3. So 2 to the -3 power is really 1 over 2 to the third, because remember, a negative exponent turns it into a fraction. So this is 1/8. So the answer here for x is 1/8. So the order pair, 1/8, comma, -3. Next, I'll plug in -2. 2 to the -2 power is 1 over 2 squared, which is 1/4. So that's my x value. So 1/4, -2. Next, I'll plug in -1. 2 to the -1 power is just 1/2, or 2 to the first power. So 1/2 is now your x value. So 1/2, comma, -1. Yes. So next, let's keep going. Let's plug in 0 and then some positive numbers. So 2 to the 0 is 1. So 1, comma, 0. Then if I plug in positive 1, 2 to the first is 2. So 2, comma, 1. And then finally, if I plug in 2, 2 squared is 4. So 4 comma 2. And let me plug in one more. I'll plug in positive 3. So 2 to the third is 8. So 8 comma 3. So now let me take this whole first column of ordered pairs and I'm going to graph the log function. It's going to have a vertical asymptote at x equals 0, the y-axis. So let me graph the ordered pairs. So I've got my asymptote here. Now, these fractions are kind of hard to graph, but again, just get them close. Show that it does not cross that asymptote. So it's negative 1 or positive 1/8, negative 3. So really close to the axis here. And then you would graph 1/4 and negative 2. And then 1/2 and negative 1. And then finally the 1 and 0. Then the 2, 1. Then the 4, 2. And then finally the 8, 3. So notice my graph, it's going to slowly approach the green line, but it's never going to cross. And if you looked in your table, notice how these x values down here at the bottom, it went from 8 to 4 to 2, and notice it kept getting smaller and smaller. So the more y values that you plug in that are negative, the closer it's going to get to 0. Notice the domain, that's the x values. Notice there's no negatives. So the domain here is going to be from 0 to infinity. So no negative numbers. So from 0 to infinity. The range, though, is all real numbers because it covers every single y. And notice my arrows on the end. So range is all real, but the domain is only everything greater than 0. The x-intercept, so in some of the questions towards the end, it asks for the vertical asymptote. So my vertical asymptote here is x equals 0. And my x-intercept is the ordered pair 1 comma 0. Now, remember, to find an intercept, the x-intercept, we set y equal to 0. Now, we already did that in the table, but in your exponential, if you take your equation and you plug in y equals 0, sorry, this is x. So you set y equal to 0. This equals x. And then we would get 1 equals x. So our x-intercept is the ordered pair 1 comma 0. But when we graphed it, we had already done it here in the table. But remember, to find an x-intercept, you set y equal to 0. Let's try another one. So remember from the homework yesterday, when you just have the word log, remember what's assumed here is a little 10. It's a base of 10. So this log x is really got a base 10. And then I can move the y to the back. So if I turn this to exponential using my Bay trick, BAE, this is going to turn into 10 to the y power equals x. Now, this time I'm not going to plug in as many. So again, I've got my ordered pair that I'm going to end up getting. I get my answer for x, 10 to the y equals x, and I'm plugging in y's. So I'm going to plug in negative 1. So 10 to the negative 1 power is just 1/10. So my ordered pair is 1/10, comma negative 1. Then I'm going to plug in 0. 10 to the 0 power equals 1. So the ordered pair, 1 comma 0. This is actually my x-intercept. And then I'm going to plug in positive 1. 10 to the first is 10. So 10 comma 1. And then if I were to plug in 10, and I'm not going to graph this one because this is 100. So 100 comma 2. So really I'm only going to graph the first 3. Now, if you did not plug in 0 in your table, remember to find your x-intercept. You set y equal to 0, which we already did. But remember the equation or the function was 10 to the y equals x. So 10 to the 0 power equals 1. So my x-intercept is 1, 0. Now I did not shift my graph. So my vertical asymptote is still x equals 0. It's still the y-axis. So I still have the vertical asymptote here. And now let me graph at least just the 3 order pairs, because I'm not going to graph 100 comma 2. So if I graph, and again, 1/10 comma 1, negative 1, again, you're going to get close, to that axis. It's hard to graph 1/10. So you could put it right here, then the 1, 0, and then finally the 10, 1. And again, it's going to slowly approach the green line, but it does not cross it. So the domain, still only positive numbers. So the domain here from 0 to infinity, and the range is all real numbers again, because it covers all the y's. All right, so these are the basic shifts. So when you have something, so for example, let's say it's log x plus 2 or log x minus 2. So when something is being added or subtracted, this is going to be the shift up and down. So when you add something, this would have been 2 units up. This one would be 2 units down. And when it's in parentheses, that's going to be the horizontal shift, left and right. So if you have y equals log, and then it's x plus 2, or log x minus 2, this one backwards of what you think when it's in the parentheses. So for this one, you would think it's to the right, but it's really going to be 2 to the left, and this one's 2 to the right. Correct. So when it's in parentheses, it's left and right. When it's not in parentheses, it's up and down. Then we also have the reflections. All right. Then the other shifts are, for example, if you have y equals negative in front of log, this is going to be a reflection. So we're going to reflect it across the x-axis. But if we have something where it's log and then a negative, then it'll be a reflection across the y-axis. So for this one, notice it's in parentheses. So backwards of what we would think. So this is going to be 1 unit to the right. So what I'm going to do is I'm going to graph y equals log x. And then I'm going to take the 3 points that I graph, and I'm going to shift them all 1 unit to the right. Now I just got all the ordered pairs for this one. Again, remember it's got the little 10 here. So this is really 10 to the y equals x. So what I'll do here is, again, the same table as before. So xy, x, 10y equals x, and then the y values, I plugged in -1. And when I plugged in -1, 10 to the -1 was 1/10. So 1/10 comma -1. When I plug in 0, 10 to the 0 is 1. So 1 comma 0. And then when I plugged in +1, I got 10. So 10 comma 1. I'm going to graph these 3 order pairs, and then I'm going to take all 3 of them and just move them over 1 unit to the right. So if I graph them originally, again, I'm not shifting it left or right. So my asymptote is staying right here at x equals 0. I'm sorry, it's going to shift. I take that back. So right now, the original asymptote is there. And let me graph the original points. So 1/10, -1, 1, 0, and 10, 1. This is the original graph. When you shift it left and right, your asymptote moves. My asymptote is moving 1 unit right. So now my asymptote is now at x equals 1, shifted 1 unit over. So now my vertical asymptote is now at x equals 1. And now I take these points and I'm moving them 1 unit over. Actually, let me do it in blue so this one shows up. It's always a vertical asymptote. Exponential has horizontal. And remember, they're inverse operations. So this one's always going to have a vertical. So then now I'll connect the points. And there's your graph. Now, we also have to find the x-intercept. Here we can see it's clearly, we just moved it 1 unit over. And this x-intercept is the order pair 2, 0. But let's say we didn't graph it, or we could also find it by plugging in. So remember, x-intercept is found by setting y equal to 0. So this was the original function. If I turn it into exponential, remember the base 10. So it's 10 to the y equals x minus 1. Because if you do your bay. So then we plug in a 0 for y. So 10 to the 0 equals x minus 1. 1 equals x minus 1, because 10 to the first is 1. Add 1. And x equals 2, which is what I found for my order pair by just shifting my graph 1 unit to the right. So my x-intercept is the order pair 2, 0. My vertical asymptote is x equals 1. And my domain is shifted now. It now is all numbers 1 and bigger. And then my range still all real numbers. So 1, notice no parentheses. Now, you may also see these written, and when I did those, showed you the example, remember I had it written as log x, and I put the +2 behind it. It doesn't matter if it's in front or behind it, as long as it's not in parentheses, this is going to be the shift vertically, up and down. So because it's a +2, this is going to be 2 units up. It's not backwards of what you think. So again, I'm going to do the basic log x function, and then I'm going to shift my 3 order pairs 2 units up. So remember, from before, the order pairs were 1/10, -1, 1, 0, and 10, 1. These were the order pairs we did in the previous 2 slides in the chart. So it's got the vertical asymptote. When you shift things up and down, this vertical asymptote does not change. So for this one, the vertical asymptote is going to stay the same. It's going to stay at x equals 0. I can graph these 3 original order pairs. And then I'm going to shift them 2 units up. So when I go to shift them up 2 units, and then it's going to skim along the same asymptote. Now, it's going to ask for the x-intercept. So remember, x-intercept, we have to set y equal to 0. Now, for this one, if you took your original, so let's say we move the y to the back, and it's log x plus 2 equals y. And if I turn this in to exponential here, let's say I plug in a 0 here for y. So log x plus 2 equals 0. We're going to move the 2 over. And then I get log x equals negative 2. Remember, this one's got the assumed 10. So if I do BAE here, 10 to the negative 2 equals x. And then here, we can see that it's 1 over 100 equals x. So 1 over 100 comma 0 is your x-intercept. It's got to be one more above, so it should have been up here. Yeah, it's 2 units up. Everybody good?
And again, when you shifted it up.
So the domain here, notice the asymptote didn't move, so it's from 0 to infinity. Range is still all real numbers.
Right, left.
This one's going to be 2 units to the right because it's backwards of what you think. This is natural log now. So ln, so 2 units to the right. Now I'm going to graph y equals ln x, and then I'm going to shift all the points 2 units to the right. Remember, the base on this is an e. So if I turn this to exponential, so for here, remember it's got the assumed little e here. So when I turn this to exponential, it's really e to the y, let me do a different color here, e to the y power equals x. This is the exponential form of the natural log. Remember, e is approximately 2.718. We're just going to use 2.7. So we're going to do a table and get 3 order pairs. So x and y, then the answer I get, and then e to the y equals x, and then the y. I'm just going to plug in negative 1, 0, and 1. So when I plug in e to the negative 1, so now this is really 1 over e, which is 2.7. I'm just going to leave it at 2.7. When you go to graph this, you can approximate this to be about 1/3. So about 1/3, comma, negative 1. Then I'll plug in 0 for y. E to the 0, anything to the 0 power is 1. So 1, comma, 0. This is also going to be my x-intercept. All right, so we plug in a 1, e to the first, about 2.7. So when you go to graph it, you're going to go really close to 3. So 2.7, comma 1, not exactly on the 3, just a little bit before. So I can go ahead and graph these 3 order pairs, and then I'm going to shift them all 2 units to the right. I wouldn't put it right on the 3, put it just before the 3.
How do you do?
Remember, when you shift your graph left and right, the asymptote is also going to shift. So right now, our original asymptote is this y-axis. So right now, it's here, and I'll graph these 3 order pairs, the 1/3 and the negative 1. And then the 1, 0, and then almost to the 3, comma 1. So this is the original natural log function. Now, I'm going to move my asymptote. My asymptote is now going to be at 2 units to the right. So now my asymptote is over here at x equals 2. So now I have my asymptote, vertical asymptote, is now x equals 2. And now I can graph and take these 3 points, shift them 2 units to the right. So if I go just in front of this, and then 1, 2, And then this one, 1, 2. And then again, it's going to skim along the asymptote. And again, you can see your x-intercept. You shifted it 2 units. So your x-intercept is actually 3, 0.
How do you find the asymptote?
If you were not graphing it and they asked you to find the x-intercept, then you would take and plug in, set y equal to 0. So you would have taken your original graph, the ln, and again, remember, assumed e, x minus 2 equals y. What we could do here is plug in a 0. So ln e x minus 2 equals 0. We could turn this into exponential form, so BAE. So it's going to be e to the 0 equals x minus 2. Anything to the 0 power is 1. X minus 2, add 2, and x equals 3. So same x-intercept I got when I just moved it and counted 2 boxes over. My domain is now shifted. So my domain now is everything bigger than 2. So from 2 to infinity, but the range is still all real numbers. All right, last one in the notes. Now, what we're going to do here is normally this number in here can't be negative. So what we have to do is we have to factor out a -1, which turns it into a reflection. Now, when you're doing the homework tonight, you're going to describe the shifts before you factor it out. So right now, this looks like it's 2 units to the left, right? Because it's a +2, and it's a reflection, and it's going to be a reflection across the y-axis. So let's go ahead and take a look here. So when it's in front of or in here, it's y-axis. So let's rearrange this. So it's ln, and it's got 2 minus x equals y. I'm going to pull out a -1 and then make this x minus 2 equals y. So it's really, and you're not, once you factor out the negative, you're not describing the shift based off of after the negative has been factored out. You're describing the shifts before you factor it out. So now let's go ahead and we're going to do the basic ln graph. So remember the order pairs for just the ln x equals y. Remember those were the 1/3, -1, and that 1/3 is approximate. And then when we plugged in, we got, it's a reflection is what it is. So when we plug in 1, we got 0. And when we plug in, did I write this backwards?
ln x, wouldn't it be ln e?
ln x e.
Well, the e is assumed. The little e is there.
So it's both. Yeah, watch out.
Okay, so now, these are the original order pairs. So let me graph them with the asymptote. So here is my vertical asymptote. And now I'm going to graph the 1/3 -1, then the 1, 0, and then almost to the 3 and the 1. So this is the original basic graph, the ln x. I'm going to reflect it first. So I'm going to apply the reflection. So notice this point is 1 unit away from the y-axis, so I'll put 1 here. This one could be the same distance away, the 1/10, and then I'll go almost to the 3 right here. So this is the reflected graph. And now I need to shift it 2 units to the right. Because now the movement is based off of this.
Minus x, so that means you reflect it on the x. I mean the y.
On the y.
And then what do you do with the 2?
The 2 backwards of what you think. So now we got to shift it 2 units to the right. So now I'm going to take all of these and go 2 units to the right. So 1, 2.
So the vertical asymptote is -2.
So now my asymptote is now here at x equals 2.
Okay, wait. So look, you reflected.
So now my vertical asymptote is now at x equals 2. And now I'm moving all of my points 2 units to the right. So once I move them 2 units to the right, I end up with and then here's your new graph. So my domain now is going to be everything from negative infinity up to the 2. And my range is still all real numbers. For my x-intercept, I can plug in a 0, but I can already see it's this order pair, 1, 0. But I'll go ahead and plug in the 0. So for your x-intercept, set y equal to 0. So ln 2 minus x equals y. Plug in a 0 for y. And then I'll put it into bay. So this is a little e. So b, a, e. So e to the 0 power equals 2 minus x. E to the first is just 1. Then I can go ahead and subtract the 2.
1, 0.
-1 equals -x. Divide by -1. X equals 1. And the vertical asymptote is x equals 2. So when you're doing the homework tonight, you're describing the shift before you factor out the -1. So the shift here, really what we ended up is it's really 2 left, however, and a reflection across y.